All right, next equation example. This one is involving a radical equation. That just means that it has a radical in it. A radical, of course, is a square root, or a cube root, or a fourth root, or any other root. In this case, I'm just dealing with the square root. So square root of 1 minus x, and then that expression minus 3 equals x plus 2. All right, well, the main way that you can deal with a radical in an equation is to isolate it on one side and then square both sides to sort of undo the square root, if your radical is a square root. If your radical were a cube root, you could cube both sides to undo that. So we're going to try to manipulate this into a simpler type of equation, whether it's going to be linear or quadratic or whatever, we don't know yet. We're going to find out. So the first thing I got to do is isolate my square root. So I'm going to add 3 to both sides. Okay, I really have to do that first because if I start squaring both sides right away, I run the risk of accidentally committing the cardinal sin of algebra and squaring all the terms individually, which is not okay. Remember how distributing works? Yeah, squaring does not distribute over addition or subtraction. So to avoid that, I need to isolate my square root by itself, right? Here we go. And so now that I've done that, we can go ahead and square both sides of this. And now we need to evaluate the squaring correctly. In the last example, you remember we took a square root of a square, and that simplified as an absolute value. In this example, we don't really need to worry about that. We have 1 minus x, and that is underneath the square root. In order for that to be a real number, the 1 minus x needs to be positive or not, or 0. It needs to be at least not negative. So that actually will restrict what the like allowable x values are. We'll get to that later. But then the result of the square root is positive. So when you square it, it's still going to be positive. There's no need for absolute values on this expression right here, because the fact that this 1 minus x is a positive number was required to begin with. We can, if you'd like, we really should do this actually. We should put a note 1 minus x should be greater than or equal to 0 up here. Okay, just to make sure that this is like a real number that we're working with. So okay, so the square root and the square cancel each other here. And over here, on the right-hand side, I have to correctly square x plus 5. You can, if you'd like, you can write out x plus 5 times x plus 5 and then do a FOIL, or you can use kind of a shortcut. Either way, we should get to the same thing, which is x squared plus 10x plus 25. All right, so now this whole thing appears to be a quadratic equation. So now we're solving a quadratic, right? We've simplified this from radical to an equivalent quadratic. And for this one, what I want to do is gather up all my like terms. I'm going to add x. I'm going to subtract 1 so that I have 0 on the left. And collecting like terms, combining them together, I get this. That is in the general form, the ax squared plus bx plus c format for quadratic equation. And so I could use my quadratic formula if I want, or in this case, it's easier just to factor. This thing factors real nicely. Let's see, this is like x plus 8 and x plus 3, right? So now we can apply another really handy-dandy tool in algebra, which is the zero product rule. Let's write that down. Zero product rule. There's other names for it, like the zero, what is this, zero product property or something like that? I don't know. You may encounter this by a different name, but it's a very simple concept. It's just that if you multiply two things together and you get 0, one of the factors in that product must have been 0 to begin with. Okay? Because if neither of them were 0, you can't possibly get 0, right? We're going to say from this that either x plus 8 is 0 or x plus 3 is 0. And then that gives us our two possible solutions. X is negative 8 or x is negative 3. But now, we can't just say that those are our answers and call it good. We should stop, because remember, we've got to make sure that what we're dealing with here is going to be, 1 minus x is going to be a positive number. Also, we need to make sure that these are actually solutions for for this equation that was originally given. We have to, when checking our answers, we have to always go back to the original equation. So let's check x equals -8. I'm going to have the square root of 1 minus -8 minus 3 equals -8 plus 2. I'm substituting in the -8 wherever there's an x. 1 minus -8 is 1 plus 8, so that's the square root of 9. Okay, that's good. So far, that's great. Because we wanted to make sure that whatever's underneath the square root was positive, at least not, or 0, right? Not negative. And that actually works, right? So that's not a problem. But that's not the only problem we could have. So let's keep going here. -8 plus 2 is -6. So now my square root of 9 is 3. And I get 0 is -6. Well, that's obviously not true, right? No. So what went wrong, right? It wasn't the problem with the domain, you could say, or it wasn't the problem with like getting a negative under the square root. There was a different problem somewhere. Well, the problem came in here. When we squared both sides of this equation, you lose information. Squaring always like erases information, right? Because you got well, was it positive or was it negative type of question there. So so actually, if we did this adding of 3 to both sides, if you do that here as well, like add the 3 over, you get like +3 equals -3, and you notice how the +3 equals -3 are like, you know, that alternative we could have gotten from adding the 3 to both sides. +3 and -3 have the same absolute value, right? Well, squaring them produces the same number. So no matter we got that, you know, no wonder we got that as a solution, because it would be a solution if you squared both sides, right? But it's not a solution to the original equation. So that's why this answer didn't work, okay? And that's why it's so important to check. We better check the other one as well, right? Because it's possible that both answers are actually wrong, and maybe this equation has no solution. That's certainly possible. So if we check, we'll put the -3 in. 1 minus -3 square root, and then -3 equals -3 plus 2. And in this situation, we get the square root of 4 minus 3 equals -1. 2 minus 3 equals -1. And yes, -1 equals -1. So in that case, it actually works. Yay. And x equals -3 is our solution. It's the unique solution. Turns out there's only one. When there's only one, you can call it unique. That's it for that one.